Wednesday, February the 3rd, 2021, 8G5. So I'm going to read that standard to us.
I can find angle relationship in triangles with 60% mastery.
Good job. On Monday and yesterday, we was looking at angles with transversals. Today, we're going to again begin to look at angles and triangles. Before we move along, there was one rule about the angles of a triangle. Anybody remember what it is?
They have to have a sum of 180.
Good job. Thank you, Reese. That's something you learned back in 4th, 5th grade. Three angles of a triangle must add up to 180 degrees. So that is the base knowledge that you would need as we are moving forward. All right, a few vocabulary. Someone tell us what a triangle is.
Triangle, the sum of the measures in the three interior angles have a sum of 180 degrees.
Good job, thank you, ma'am. Y'all should know by now. Waiting on me, we'll be here. Adjacent angles.
Angles that share a common vertex and side beside each other.
All right, one thing to remember about adjacent angles are that they are beside each other. That's something we learned last year in 7th grade, but if we forgot, they are beside each other. Looking at this picture, these two angles are considered adjacent because they are right there beside each other. All right, someone tell us about an interior angle.
One of the three vertices of a triangle.
Interior angle is any of the three vertices of that triangle or any angle on the inside. As the picture shows, one interior angle, but all three would be considered interior angles. All right, someone tell us about an exterior angle.
Angle formed by extending one side of a polygon past a vertex.
Good job. So anytime we extend that angle beyond the end of that triangle, it's considered an exterior angle, as you see in the corner. It's on the outside, meaning exterior, outside, interior, inside. Those are words from ELA that we should recall from many years ago. All right, someone tell us the next bullet.
The measure of an exterior angle plus the measure of the adjacent interior angle have sum of 180 degrees.
Good job, thank you, sir. If you recognize in the diagram, this exterior angle and this interior angle made a straight line. Anytime I see straight line, I should automatically think of 180 degrees, meaning if I know one, I will be able to figure out the other. All right, someone give us the next.
The measure of an exterior angle equal the sum of the measures of the two non-adjacent interior angles.
Good job. So if I know the measure of this exterior angle, I can find it by doing those that are not adjacent to it and add them together, and that would give me the measure of that exterior angle. The two that are not adjacent to it, meaning the two that are not right beside it. All right, down at the bottom, someone told us about similar triangles.
Similar triangles. Corresponding angles are congruent. Can I say the triangles are congruent if you don't know the side length?
Good job. When they give us only angle measures, we could not say that we have congruent triangles. Because remember, congruent means the angles are the same and the sides are the same. But if we do not know the sides, we cannot say that. Looking at this example of these two triangles, 60, 30, and I know if my sum has to be 180, then I know this other angle must be 90 degrees. So that means in the other triangle, that other missing angle will also be 90 degrees. All because they have the same angles, they are known to be similar triangles. I cannot say they are congruent because I do not know those side lengths. So those are some things to make sure you pay attention to. Any questions about it? All right, someone read the top of that.
You may use angles dealing with transversal as well.
Thank you, Cameron Hall. So although we're moving with triangles, we may still see some transversals and need to recall some of that vocabulary as well. Who remember what we said about corresponding angles?
Angles that sit by each other and have the same measurement.
Good job. They lie in the same position and they have the same measurement. What about vertical angles? Interior angles.
They're on the inside.
All right, they were inside the two lines. Exterior angles.
Outside.
They were on the outside of the two lines. Supplementary angles.
They add up to 180.
Good job. Complementary angles.
They add up to 90 degrees.
Good job. Alternate interior angles.
Inside parallels on opposite sides of the transversal.
Good job. They're opposites on the inside. Alternate exterior angles.
Opposites on the outside.
Good job. That is correct. Opposite on the outside. And then we had same side interior angles.
On the same side on the inside.
Same side on the inside, and they are supplementary, add up to 180 degrees. Remember I told us yesterday, knowing this vocabulary pertaining to angle will help us eventually in which class?
Geometry.
Good job. So that means if I learn it now, I won't struggle to get it when I get to Algebra 1 in geometry. It's all up to you. All right, someone read that to us.
Do not be afraid to draw on the shapes. Make sure you can identify the relationship between the angles. Be able to prove helps when you get to geometry in high school.
Good job. So do not be afraid to draw on your shape. If they tell me what one angle is, I'm automatically questioning myself what other angle will have that same measure. And then, of course, it's going to help us in geometry. Make sure you're able to prove. When you get to geometry, you'll have to say this angle is equal to 63 degrees because together they are supplementary. So that's why I'm trying to help you now learn the vocabulary so that when you have to prove it, you will know exactly what you're stating. All right, your practice is found in Schoology as always. Thumbs up, shake your head, type yes, I made it in the chat. My 7th grade complete their entire practice every day. It should be y'all. Somebody read question 1. I like it.
In triangle PQR, angle P equals 30 and angle M equal and angle Q equals 60. In triangle SU, angle S equals 30 and angle T equals 60. How do you know that angle R equals angle U? How can you prove this using the fact that the measures of the angle in a triangle have a sum of 180?
How can we prove that R and U will have the same measurement?
By adding up the angles and then seeing what else we need to get 180.
What else? What do you recognize?
That they right angles, but they usually
And why can you say they're right angles, Ryan?
they equal 90 degrees.
No, they equal 90 degrees. That's what they asking you. How can you prove it? Meaning, what tells you that those angles are going to be 90 degrees? See,
Because 90 minus 180.
go ahead, Brian. I was trying to read the chat.
Oh, I was just saying that 180 minus 90.
Meaning they want you to prove it. Meaning every step you take, we know 30 and 60 is 90. So then I would say 180 minus 90 is equal to 90. They both had what two angles? Got the drummer in the chat box trying to get you a few participation points. Gotcha. They both had, no, they both, from what we can see, they only had 60 and 90 degrees. So common sense would tell me, okay, that other one, if I subtract, will be the same for both because they both had the same two angles. I don't get a grade on purpose. All right, somebody read question 2 to us.
Explain how you know that M1 plus M2 plus M3 equals 180.
All right, so look at the measure of angle 1, 2, and 3. What do you recognize about 1, 2, and 3 for them to say that it's going to equal to 180 degrees? All right, it made a line. And I know a line adds up to good job. That's a few of you. All right, looking at part B. Somebody read it to us.
Lines M and N are parallel. What is the relationship that tells you that each statement is true?
All right, so they said the measure of angle 1 is equal to the measure of angle 4. Look at angle 1 and look at angle 4. What can we say about angle 1 and angle 4 for us to say that they have equal measures? What could we say about angle 3 and angle 5 to say that they have equal measures? Good job, Lakeland. They are alternate interior angles. meaning they are on the inside of the two lines, on opposite sides of the third line. Alternate interior angles are equal, have the same measure. Questions about it? All right, someone read number 3 to us.
Use the fact about triangle angle sums and similar angles to solve this problem. Triangle PQR and triangle STU are similar angles. In triangle PQR, QPR equals 60 and PQR is a right angle. Explain how you can solve for X.
All right, they told us these are similar triangles. Similar triangles have corresponding sides. Similar triangles have corresponding sides. So then I take note of how they gave the triangle. PQR and then STU. So that means P is going to be similar with S. Q is going to be similar to which one?
Q similar to T and RC.
Good job. All right, so based on us knowing that, we got P over here 60 degrees, and you just said P is similar to S, so that also means S is also 60 degrees. Q was 90 degrees, so that meant T is also 90. So now they want us to figure out how can we find X? What do we know about X? What kind of angle is X?
Exterior angle.
Good job. How can we find the measure of an exterior angle?
First, find U and then take 180 and subtract the U.
Okay, that's one way, Lakeland. So we can find U by what we know about triangles. I'll put that there. Find U by adding your 60 plus your 90, and that'll give us what?
One-fifth.
Okay, I thought I had to go back to elementary. Thank you, Edward. So that's 150, and then she just told us that it'll make a straight line, meaning 180. So 180 minus that 150 tells us that U is equal to how much? Well, not U, because U was on the bottom, but that other piece in that triangle is equal to how much?
130.
30.
All right. So that means on the inside is 30. She told us all of this has to equal to 180. So then I use my common sense again. So X must be equal to 150 degrees. And this is what I was telling us up top. The measure of an exterior angle is found by finding the sum of the two non-adjacent angles. So without us having to find the measure of 30, we could have just added the 60 plus 90, and that would have gave us the 150 for X. Any questions about how we can find that exterior angle? I read question 4 to us.
In the diagram, angle ABC equals angle DEC. Explain how you know that angle ABC and angle DEC are similar triangles.
I'm sorry, I had a phone call. All right. So they told us A, B, and C is similar to D, E, C. And they want us to explain how these two triangles are similar. All right, one way to think about that is to separate the triangles, or try not to look at them all the same. So I'm gonna take out my big triangle. That's gonna be my A, that's gonna be my B, and that's my C. So do not look at that part for DEC. How can we explain that these two triangles will be equal?
Say that again, McKay.
How can we explain that these two triangles will be equal or similar, meaning their angles will have the same angle measures?
It's over with. Oh yeah, we're going away. Come here. Yes, sir. Come on, man.
Which angle stayed the same in both of them? Good job. So that's the first thing to note. Angle C, and that means the measure of angle C is the same in both. All right, what do you recognize about A and D?
It's what do you call it? It starts with the I.
All right, so
Makes
if
a
I
straight
was
line.
to make, I kind of get what you mean, Lakeland. A reset a line. Okay, so if I was to continue these and make some more lines, what can you recognize about A and D? What kind of angles are they now? Start with a C.
Congruent.
Another C. C-O-R.
Corresponding.
And what do we know about corresponding angles?
As in the same position.
They're in the same position and they are congruent. And that would mean the same for B and the measure of angle E. Any questions about it?
Hold on, Miss Hitchens.
Okay.
I'm done.
All right. All right, someone read question 5 to us.
You use similar triangles to explain why the slope M is the same between any two distant points on the line shown.
All right, now when we discuss slope, we discuss triangles, making triangles and being on the same line. Anybody recall? It's a constant rate. All right, you said the key word, constant rate. So that means they're gonna have the same what? What is the question asking?
Same measurement.
What is the question asking us to explain? Rate, rate, rate. Rate is another name for
Slope.
Somebody said it. That you, Mariah? So that means if these points lie on the same line, we have the same slope. That's all we learned when we talked about slope. So that means A, D, C, and F will have the same slope. So these two triangles will be similar because their points lie on that same line. All right, somebody read 6 to us.
In the diagram at the right, show that angle ABC and angle EDC are similar triangles. Then find angle CED.
All right, so first they want us to explain how they are similar. All right, look at ABC. We know C is 50 degrees, B is 90 degrees. We don't know A. And then we got EDC. D is 90 degrees. Do we know any other angles in EDC?
We know
C would be 50.
Good job. C is 50 again. Who knows why? What kind of angle is this C and that C?
Vertical angle, right?
Good job. Vertical angles are congruent. All right. So C is 50 and that's 50 and the other one is 90. What can we say that would explain why these two triangles are similar? What do you now recognize?
they
They got the same measurements.
All right, both triangles have two of the same measures, which is 50 and 90 degrees. So what else does that tell me?
That whatever A is gonna equal the same thing as E.
Good job. So after I add those, I can subtract from 180, and that will tell me that the measure of angle A and the measure of angle E will be the same because they both have two of the same measures. So that means their third angle will also be the same. All right, they then asked us to find CED. CED. That's over here. Now they want us to find that. Okay, I guess the second part of that, we'll figure it out. Read 7.
Are the triangles shown in the diagram at the right similar? Use angle relationship to explain how you know.
All right, what can we do with these triangles to help us try to figure out if they're similar?
I think since we don't know B, that B and F would probably be the same angle.
We can't figure out what's the same yet until we figure out what we know. So before you say they're the same, give us some background information to help us see why they're the same.
We can add up A and C, subtract it from 180, and see if it'll give us the same exterior angle as angle FED.
So stop right there. You just stated it. Add those two together and subtract from 180. So 70 and 65 is about what? One. All right, Jeremy over here saying so that missing angle would be 45. All right, so what can we do in this other triangle to help us figure out those other angles?
We have to say 180 minus 115.
Why?
Because it's a straight line and it would make it like a straight angle, I think.
All right, because the exterior angle and the interior angle made a straight line. Remember they said explain. This is something you're gonna have to do when you get to geometry. You just can't say, oh, this is gonna be 45. You're gonna have to go into detail with why you saying it's 45. All right, so did you subtract it, Lakeland? What you got?
$165.
Go with 65. You kept your 1 in the front. That's all right. All right, so if that's 65 and we know this is 45, then what can we possibly say about D? Three angles add up to 180. So if I know 65 and 45, what's my third angle?
$70.
Okay. So that third angle would be 70, just as the third angle in the other triangle. Questions about it? All right, that's 7. That means you got 8, 9, and 10 left to do. Quite a few of you. I still have sent you emails about work that you still have not completed. Some of you, it seems like you haven't even attempted to complete it. Remember, work is due by tomorrow if you expect it to be reflected on your progress report on Friday. I read math, diagnostics, some of you still have not completed. STAR math, you still have not completed. And both of those need to be complete by Friday as well. So make sure you are doing your part. Have a great Tuesday.